Hi friends, this is Eric White with OpenXMLDeveloper.org, and in this screencast I'm going to walk through the code that uses MSMQ to push all OpenXML functionality out into its own executable and into its own process. This is the code that I demonstrated in a previous screencast building high-performance OpenXML applications. This is the code that makes it so that we can avoid the spurious object-disposed exceptions or null reference exceptions that we can see thrown from deep inside system.io.packaging. It's not very complicated code, but it's worthwhile to walk through so that if you need to develop code along these lines, this will make it pretty easy for you to take this code and repurpose it for your own scenarios. If you'll recall, in the previous screencast, there are two executables that I demonstrated. One of them is a daemon that does the actual document generation or document manipulation. This daemon is an executable you would probably want to have automatically start as soon as you boot the particular server that this daemon will be running on. Up at the top here we see a couple of static variables. One is the address of the queue that lives on this particular server, and I took the approach of making all of these queues private queues. There's no reason to do otherwise. Private queues doesn't mean that they can't be accessed from another machine. They're simpler to access. So the name of the private queue when you access it on the server itself is $private$/generate documents. In other words, a message coming into this queue means that the daemon is supposed to generate a document. There's also this static message queue variable that gets initialized. Here we can see the main function is as simple as it could be. There's this initialize method, and then there's a message loop method. We can look at the initialize method. It's super simple. It looks to see whether the specified queue exists, and if it does exist, it deletes it, and then it creates that same queue. So when this process starts, it's going to clear out that queue in case it already existed, and then it's going to create a fresh queue. In this code, I've documented the XML that gets passed back and forth. I determined that it's easiest to pass XML back and forth as the actual payload of each message in the message queue. This gives us a lot of flexibility about what exact information we want to pass to this daemon and what information this daemon will pass back. So a message coming in is going to have the message label of generate documents, and in the payload of the queue it's going to have this root element generate documents, and it's going to also contain here the name of the return queue that this daemon needs to send a message to when it finishes generating the document. It also has the path of the template document. You could certainly make this system as sophisticated as you want. Maybe you'll use one particular template document for one particular document generation scenario and use a different template document for another scenario. It also has the location where the daemon is going to place the generated document or documents. In this example XML, it indicates that it's going to put it into a folder in the public documents directory. In more sophisticated scenarios, this might point to a network share or some other resource that is accessible both from the daemon and from the process that is sending a message to the daemon. If they're both running on the same machine, of course, then this is super simple. But if they're running on separate machines, you're going to have a directory that both have access to. Then there is this document generation data element. And this element contains the data that is going to be used to generate the particular document that's being requested. So this will be specific to the template document that you're using. If the template document changes, then the XML that is inside of this document generation data element, that XML will change. The return message back from the daemon couldn't be simpler. It's going to have this documents generated root element, and then it has a list of any number of documents. I took the approach of naming each document with a GUID. This keeps things simple so that I don't have to go and look to see whether the particular document exists or not. I just name it based on the GUID, and I'll know that that particular GUID doesn't exist in that directory. Here's the message loop. It says, while true, it receives a message here from the message queue. And this code right here gets the body of the message as text. And then if the label of the message is generate documents, then this code here parses that text and creates an XML tree, this generate documents arguments. That's going to be an XElement object. You might, in some scenarios, want to do schema validation of these messages back and forth. In a really robust system, you most probably would want to do this, but this is straightforward schema validation. I'll leave that as an exercise for you. The code then here, first of all, it retrieves the return queue name. It gets the template document name. It gets the directory where we're going to put the generated documents. And then it calls this document generator .generate documents method, passing in the template document name, passing in the data that's in that payload of the message. This is the data that we saw back up here at the top. It's the document generation data element, the contents of that. And it also passes in the directory name of the place where the document generator is supposed to generate documents. When this document generator gets done, it passes back a list of names of generated documents, and as you saw, those will be named with a GUID. It outputs a little bit of information to the console so that we can see that the daemon is doing what it's supposed to be doing. It simply says what the names of all the documents that it generated are. And then it, first of all, initializes the message queue for the return queue based on the data that was sent into it. It then creates a new message object. It fabricates the XML right here for the payload of the message going back to the process that requested the document to be generated. And down here it sends the message, and then it continues on with the loop. And if we received any kind of message other than our generate documents message, then we'll get an error here. It'll throw an exception, as it should. That would mean that we did something wrong in the coding of this particular daemon or of the process that is using this daemon. Down here is the document generator class. I took this class wholesale from a document generator that I built some time ago. It was probably 2 or 3 years ago. If you want to learn more about this document generator class, you can go to this link And there are a couple of screencasts that talk about this document generation system, this super simple document generation system. You can see it's actually only about a couple of hundred lines long. It's super simple. So that's the daemon itself. Let's go back and look at the example program named Web Server docx generation. This is an example program that is pretending to be a web server that periodically requests that the daemon generate documents for it. Up at the top here, we can see the local name of the return queue. So this name is Generate Documents Client, and it's a private queue on the computer that is requesting the document be generated for it. There's an interesting characteristic to MSMQ. The way that you format the name of a queue is different if you are formatting the name of the queue on the machine itself or if you are formatting the name of the queue on a different machine. So in this example, I have two modes that the example can run in. If you saw in the previous screencast, if you set this to true, then it's presuming that both the web server and the daemon are running on the same machine. And so here we can see the return queue local name is $./private$/generate documents client, and the return queue remote name is exactly the same because both processes are on this same computer and they can refer to the queue with this given name. However, if you change it so that the example program that's pretending to be a web server is running on one machine and the daemon is running on a different machine, then the return queue local name is the same thing. This is what the web server refers to as its generate documents client queue name. But the return queue remote name takes this form right here. And so this is where we have this string format name : direct = os : iwin. That's the name of the computer that the web server is running on /private$/generate documents client. So when we refer to the queue on the machine itself, we use this name. When we refer to the queue from another machine, we use this form of the queue. And so that's why I have these static variables up here. These static variables configure the names of the queues in an appropriate way so that if you're referring to the queue on the same machine, you use the local form. If you're referring to that queue on the other machine, then you use the more elaborate form where you use the machine name as part of the name of the queue. This is just an artifact of using MSMQ. We can see also here the differences are that the template document file info, this is stored on that Mini1 server. The generated documents directory, that's also stored on a public share on that Mini1 server. And the name of the queue on that remote machine is this form right here. Just as when that machine needs to refer back to a queue on this machine, when this machine needs to refer to a queue on the machine that's running the daemon, it has to use the more elaborate form. It's a little convoluted, but it's really not that awfully difficult. It just means you call the queue by one thing when you're running on the machine itself. You call the queue by another thing when you need to refer to that queue from another machine on the network. So now let's walk through the code. Again, just as with the daemon, there are a couple of very simple methods. First of all, there is this initialize method. It looks for the generate documents directory, and if it doesn't exist, it creates it. And then it looks for the existence of the return queue local name, and it creates it if it needs to create it. Otherwise, it just news up the return queue local name. Here I have the exact same comment in the example program that's pretending to be a web server. This is the documentation of the XML payloads that get passed back and forth in the queue messages. And here's the generate documents method, and it creates the generate documents queue from the remote name. So in other words, this here, this generate documents queue remote name, if we're running remotely, then it's going to be this name so that we can refer to that queue that's on a different machine. Then it iterates 0 to 1,000, generating the exact same document in this particular scenario. I'm more interested in demonstrating the plumbing of how MSMQ works and how we would put together an example program that requests documents to be generated by the daemon than an actual real example. So here it puts together the XML that is going to go into the payload of the message. It specifies that the label of the message is generate documents, and this corresponds to this test right here. This test is looking for a message that is called generate documents. So here it's specifying that this label is generate documents, and it's sending it to the daemon, and then daemon looks for a message with the label generate documents, and then it sends that message. It then turns around and receives a queue, and it blocks on receiving the queue. There are various options here. You can set an option such that it'll time out after a certain amount of time, and if it times out, you can go take other actions and then later on receive the message again or wait for the message again. These are all part and parcel of how you work with MSMQ. So it receives this message. When it gets the message, it's looking for a message with the label of document generation complete, and this corresponds to the sending of this message right here, and the label is document generation complete. And when it gets this document generation complete, it gets the XML payload that contains the list of documents that were generated. After it gets that payload, then it just, in this particular small example, it just goes through and says, yes, this document was generated, and prints out the name of the document, which is a GUID, as we saw. And then in this particular case, just because we're keeping this sample simple, it just deletes that document in place. If we were building a real application, this would be where we would do whatever we want to do with that generated document. And that's it. So you can see that the web server docx generation program is super simple. It's a grand total of 149 lines of code, and the other one isn't that much bigger either. So now let's run through this and see the generation of all of these messages and how these messages flow back and forth between the pseudo web server and the document generation daemon. So I'll start up the daemon first. The daemon comes up to this initialize method. We go inside. It looks for the existence of that generate documents local queue. It deletes it and then creates it. It then goes into the message loop. And the daemon now is waiting for a message to be sent to it requesting that it build a document. And it blocks here. It's blocking in this receive method. Now let's go over to the web server document generator, and I'll press F5, and it first goes into initialize, and it looks for the existence of the return queue local name, and if it exists, it deletes it, and then it creates it. Now the generate documents method is going to first new up the generate documents queue remote name. In this particular case, it's still the local form of the generate documents queue because we're running this all on a single machine. I'll press F10 and I'll go into this loop where it's going to generate 1,000 documents. It's going to put together the XML that is the payload that goes to the daemon requesting that it's going to build a document of a particular type. Here's that XML that we saw in the comments in the two examples. It then puts together a message to send to the daemon, and it sends the message. So now we can see down here this is blinking because the daemon has now received a message and proceeded on to the next statement. It has this message text. If we were to look at it, there is that XML that we sent to the daemon. Is looking to see if this label is generate documents, and it certainly is because that's what the label was set to in the sending program. It parses that XML. Now we can see that XML in an easier fashion. It's the exact same XML that we saw in the pseudo web server. It gets out the queue name, gets out the template document name, it gets out the generated documents directory, and then it generates the documents using the document generator class. It goes through and prints out a little bit of information to the console, and we can see here, yes, in fact, the daemon did generate that document. It now puts together the message to send back to the pseudo web server. It puts together the XML that is going to be the payload for that message, sets that into the body of the message, and sets the label to document generation complete, and then it's going to send that message back to the pseudo web server. I'm back in the pseudo web server, and I'm going to F10 to this point in time, so now it's blocking, waiting till it gets that message from the document generation daemon. So when I press F10, we can see now, this is blinking down here, because the pseudo web server has received that message. It gets the message text out, it gets that label and sees if the label is document generation complete, and in fact that's what the label is. It parses the XML out, and we can look and we can see, yes, there is the XML that came back from the document generation daemon. It then does whatever it needs to do with that document. For the purposes of this example, all it does is just delete that document. I don't want to leave them around. If this were a real web server, this would be where you would, for instance, provide the end user with the option to download the document, whatever you need to do with that. Here it just deletes it, sleeps for 100 milliseconds, and then goes back and does it all again. So this is how these two executables send messages back and forth using MSMQ so that all of the document generation is done in a single executable. And because all of the document generation is done in a single executable, then system.io.packaging will use just one directory for its isolated storage, and there will never be a conflict in that isolated storage because more than one process is attempting to access that isolated storage at the same time. So, that's a little bit of journey through some code that sends messages back and forth, but there it is. It's really not that awfully complicated. It's pretty straightforward inter-process communication using MSMQ. That's all I'm going to cover in this video. In the next video, I'm going to proceed on to the case where we need to do ultra high performance document generation. This would be a scenario where, for instance, you might be an insurance company that on a given day, you might need to send out 100,000 statements to users. And you're using OpenXML to generate very nicely formatted statements that you are going to send to each user. And if you need to generate enough documents in a short amount of time, you may not want to do it in a single-threaded fashion. You want to use the full capabilities of a document generation server. Maybe you have a 12-core machine with lots of memory and lots of solid-state drives, and you want to get really high performance when you're generating documents. And if you were to take the simplistic approach of simply making a multi-threaded application that does document generation on each one of those threads, and if your documents happen to be large enough that you start using up to 10 megabytes of memory, then you're going to start seeing the object disposed exception or null reference exception that is thrown from deep inside system.io.packaging. We are going to make use of MSMQ to enable really, really high performance document generation without ever causing the situation where more than one executable is using the same instance of isolated storage, and therefore we won't ever see this spurious object disposed exception. That's all for now. See you in the next video.